Okay, moving on now. We're going to move into plotting reflections on curved surfaces. And we're not going to go for the full construction on this one quite yet, but I want to talk about this and get you thinking of draft views, basically. So thinking about these views from when you start thinking about plotting reflections, I want you to think about them in individual views, and then you're going to combine those views, like a side view, a top view, a left-hand view, for instance, to help you plot and predict where the reflections will be in perspective. So let's just look at this scene for a moment. So in this scene, I've got a matte cylinder, and I've got this ball, tall cylinder here, stripe on the ground. Now we should talk about our environment. Our environment, we're out on all these settings. The previous boxes are just out in a classic desert scenario. So imagine like dry lake bed, a low ring of mountains around that lake bed, and a clear blue sky. So I would want you to estimate and think, where would you see the reflection of just the environment? Let's not even worry about these objects for this example. Let's just think about, okay, the ground and the sky. Okay, we have this. There's no radius on this. It's just a straight up cut cylinder. So on that matte surface, where would I see the reflection of the sky and the ground? So think about that for a minute. You can pause this and then think and try to predict where would the sky and the ground be. And, would we see the mountains on there? That's a nice thing to try and think and predict. Now I'm going to give you the answer. And let's draw first a little side view. I'm just going to draw over the top of this. And I'm going to say that that is our cylinder. And where is our eye? Where is the camera? Okay, that's a question. Well, I can actually tell you where the camera is in relation to that cylinder because I can look at this ellipse on the top and I could say, well, that's probably about a, I don't know, 20 degree ellipse, maybe 20, 25. And had I drawn this, and if I just draw through it, I could probably see that the cylinder on the bottom is maybe like a 35, 40. So if I draw from the middle of my top surface at a 20 degree line, let's see, there's 90, 45, 22. That's probably close enough. Okay, and I go to the middle of the bottom cylinder of the ellipse, and what did I say? Close to what looks like about a 45. So about a, let's see, 90, 45-ish, probably right somewhere, right around there is our camera or our eyeball for this scene. So now based on that, I can actually start to think about the reflections. Okay, and I can look at this and say, well, here it's hitting this vertical side and it's bouncing off at an equal angle. So I'm just going to predict that angle out, something about like that. So that's where it would point down to the ground. And then here, if it's 20 degrees one way, it would be 20 degrees the other way. So that right about there looks pretty close to being equal angle. Again, just estimating that. If I had a protractor, I could measure that, right? So what's that telling me? Well, that's actually pointing up to the sky, right? It's not pointing down to the ground. It's not going down. It's going up. What's up is the sky. Okay. And what about this side? Well, anywhere I draw, even all the way right up here at the top, it looks to me that equal in, equal out is going to point right down to the ground. So I'm going to say the sides of this cylinder should just be reflecting the ground. Oops, let me grab a brush. Should just be reflecting the ground sort of right around here in our scene. Not even getting close to the mountains. See where it hits the ground right there? And that was right at the very top. And that was on the side where it hits the top. Now, anywhere across the top, all my line of sight rays are going to bounce up to the sky. So I'm going to guess this is all sky, and this is all ground. So let's see what we have. Sky and ground. Excellent, just what we predict. Okay, now what about the placement of like where is the ball, for instance? So what you want to start to do to predict those kinds of things is you want to start to think about these scenes in top view. So if I had my cylinder, let's see if I can draw a better circle, a little bit better, and I thought about this in top view, and I knew my camera was actually a little bit off center, so it's sort of in line over here. Let's see, how far away was it? You know, if I had the right proportion here, we could start to guess that it was like maybe 1, 2, 2.5, 3 diameters away from this, maybe 2, 2.5. So let's say the camera's right out here somewhere, and the ball was kind of in line with this side, and it was maybe, you know, it's maybe short of 2 diameters. Somewhere right about here is our ball. So if I look at my sight lines, what you want to start to think about from my camera, so right about there, that's kind of straight back almost at me. Let's go a little darker with that so we can see it. So I'd say right about there, equal in, equal out. I mean, I don't have a perfect circle drawn there, but that's going on to the side of the ball. So probably right about in here somewhere, and it would hit, and it would bounce, and it would point towards the ball. So I would say just left of center. So based on this, there's center line, and there's my center line of this guy, right? Actually right there from our camera would be center line. So I'm going to say, oh, just to the left of center, somewhere along that line is probably where the ball is. So it's somewhere there. I don't know how high up and down. If I went back to my side view, okay, and I found my camera again, and I thought about, and I knew where the ball was, if this was all accurately drawn, you could just start to say, oh yeah, probably, yeah, right up in, maybe up in there somewhere is the height. So if I put those two together and say, well, it's along this line, and it's, oh, maybe, you know, guessing, it's probably going to be squeezed a little bit. We'll talk about that in a minute and why that happens. Oh, I'm off a little bit. That's where it actually is. Not bad. The height was pretty good. Again, not drawn accurately, the proportions, etc. But yes, it is a left of center, and it is, you know, a little bit higher up. So pretty close. That is what we're going to move into next. Most importantly, what I wanted you to think about here was sky and ground, and where is your line of sight bouncing. The classic thing, I've shown this to classes many, many times, and not given them any information, and not even had the cylinders, the stripes, or anything, just the matte cylinder in this desert scenario. And I've said, okay, look at the environment around the object. Now predict the reflection of the environment in that cylinder. And I can't tell you how many times you see reflections like this: mountains, ground, right, that sort of thing. And it just doesn't happen. It's not a vertical horizon, it's a horizontal horizon. This doesn't even get close to seeing, our line of sight does not bounce that far out into the environment. It really only sees what's around it here. And then, you know, this is all sky. Okay, and then this is just all ground, no horizon. Okay, if the cylinder was taller, then yes, we would start to see the horizon. Okay, because then our line of sight would bounce out to the horizon. In fact, that's a good thing maybe to talk about, is where do you see the reflection of the horizon? Well, the general rule, if it's this kind of simplified environment, wherever your line of sight bounces parallel to the ground, okay, this is to the ground plane. So let me do a little schematic for you here. This will work. Let's just do this. I'm going to redraw my ground plane. I'm going to draw a tall cylinder like this, and I'm going to say our eyeball is here. Okay, now my line of sight is going to come over to here, bounce into that cylinder. This could just be a vertical mirror as well. I see, oh, well, there it's bouncing into the ground. Same, that was just like when the cylinder was short. Okay, what happens if I go over here? Well, here it bounces up to the sky. Okay, well, between the sky and the ground here, there's a horizon. So wherever your line of sight, okay, my eye is on the horizon there, would bounce in and bounce straight back. Wherever, and this is the rule, this will help you for plotting where the horizon line is on a curvy shape. Wherever your line of sight bounces parallel to the ground plane, so this line and this line are parallel in perspective, okay, that is where you put the horizon in your reflection. So, and the reason for that is that parallel lines converge to a single vanishing point. So that means that this line in side view, right, it's just a draft here, this line on the ground eventually is going to converge with this line because they're parallel. And parallel lines in perspective converge at the same spot on the horizon. So if they converge at the same spot on the horizon, that should be where the reflection goes. So it's kind of reversing it and mapping it back up onto your cylinder. Okay, so that's it for talking about some basic curvature, and now we're going to plot one that's a little bit more complex. So let's do that next. Okay, moving right along. Let's talk about a horizontally placed cylinder. Again, you can imagine it's going to be the same sort of thing, bouncing your sight lines into a shiny shape, and then seeing where they reflect into your environment, and then taking those points that are in your environment and mapping them into the shiny reflective surface, which is all there is to plotting reflections. So you've got to get really good at this if you want to start getting good at guessing where to put your reflections. So you can use these constructions, but when I'm doing them, a lot of times I guess, but this is what's going on in my head when I'm guessing. So you might see somebody who does lots of car designs or does automotive renderings. This is what's happening if they've got a good mental picture of it. This is basically what happens inside the computer as well. So this is the mental image you need to form. So let's talk about this. I have a horizontal cylinder lying in that same desert scenario, and I have a red vertical cylinder here in the foreground. I have a little ball on the ground. Here's my camera. So you have all four views, well, three views here and a perspective view. So this is our camera view in the upper right. Here's the top view to the left, upper left, side view on the lower left, and then here on the lower right we have basically the front view, including the camera in all three views. So with this, we should be able to predict where the reflection of the ball and the reflection of the horizon and the reflection of this foreground cylinder will be in that surface. So all I did there was just highlight the center of that for you. Again, I'll give you this file. You'll see I made a little path layer here. That's a really great one to have. That's just anytime you want to find a vanishing point or radiate from a point, you just take a path like this. And what's nice about it is you can always go back and grab that point and move it around. So if you're going to a vanishing point, you're going radiating point from a light, or in this case from a camera. Looks like I've got one dead one there. I could probably just leave that alone. Needs to get reconnected. So unselect that. And then when I mirrored it, I just mirrored my whole path, put it over to get all these lines bouncing out at the exact same angle, which you'll see here in a moment. So that's how I drew all those lines. I didn't use a line tool, just stroked a path with a small airbrush, or a small regular brush probably. So those are my sight lines from the camera. Now what I want to do in the top view is I don't want to think about the curve. Okay, I'm going to think about the curved surface in the side view, but not in the top view. The top view, I just want to think about this being a straight, flat, mirrored plane. All we need out of the top view information is we need to know the placement of this cylinder, the placement of the ball, and how fat or how wide they are in that surface. So I take the white lines in, and then the blue lines bounce. That's my line of sight bouncing out. So let's zoom in on this top view a little bit. Okay, now I can see that the ball is between this line and this line. Okay, let me grab something to draw with here. Yeah, there we go. I'll put a notes layer on top. Okay, so the ball here is between, and it's set over to center just a little bit. So I'm going to guess that it's probably centered there. And if I ran the sides of it back, it's probably going to be somewhere about there. Okay, and if I look at this guy, right, for the big cylinder, well, there's one side here, one side here. So one side is just a little bit past this blue line, so I can just estimate that's where it goes. The other side is showing up not quite halfway between those two, so that's where that side goes. So that's the placement, right? I'm not drawing them on that curved surface. I'm just placing. I'm just trying to find what is the width, okay, of this cylinder in the reflection and this ball in the reflection. Same thing. That's all I care about in this view. Width. Okay, we're done. So now let's go down to the next view. So here in the side view, I have one errant line in there, it looks like, is where is the position on the curve. That's what I care about. So now I've got the curve, and I want to know where does this ball reflect, and where's the height of the cylinder, and where's the horizon line. So we take a bunch of sight lines, bounce them in, bounce them out. Okay, and let's zoom in here, and let's see if I can get this to fit. Yes. Okay, sight lines come in, and they're bouncing out all over the place. But again, it's always equal in, equal out. So that's going up to the sky, sky, sky. This one's right back to the camera. And right about, let's see, this line coming out of here, that one looks like it's going to hit the top edge of the cylinder. So that would be the height. That's the top of the cylinder. Where's the bottom? Well, it looks to be just below this line. So if I go over here, that's just below. That's the height of our cylinder in the reflection. Okay, and then what about the ball? Well, the ball looks to be a little bit, it's right on that line pretty much. So it's going to be a little bit above, I'm trying to pick a different color here. White maybe. It's going to be a little bit above the bottom edge of the cylinder. And then the bottom of it is, looks to be, if I look here, about in the middle between this line and this line. So that puts the bottom right there. So that's the height of the ball. That's the height of the cylinder. Where's the horizon line? Where, what I said before was that wherever your line of sight bounces off parallel to the ground plane, well, this line here, the blue line, is not quite parallel. This is not. It looks like a line right between them probably would be pretty close. Maybe up just a tick. Right about there would be parallel to the ground plane. Again, parallel lines, right, converge to a single vanishing point. So it looks to me like that's going to be a little bit below the top of the cylinder. And that is all we need to plot the reflection over here in the camera view. So I have a couple section lines on here. Had I drawn this, I'd probably have a few section lines on it as well, so that would be helpful. So try to remember that. If you don't know the sections of your reflective surface, you're going to have a really, really hard time trying to plot the reflections across it. So you need section lines. You need to understand all of the surfaces of your shape in order to plot the reflections. Okay, so what's next? Next is to predict here and see how close we get. So what I'm going to do is I'm going to count a couple of these sections and then place those things. All right. So I said that this guy was, looks like in the middle. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right there on that line. Looks to be a little bit off center, somewhere over there, looking at where those lines are. And then how high up? Well, I can, if I zoom back in on that, I would see that it was just right above center a little bit in there. And so this is my guess at it. Okay. And then the ball, let's see, 1, 2, just short of 3. It looks to be right along this section line here. And what was the height? Oh, it was based on the cylinder. It was a little bit, the top was a little bit above the bottom where it hits the ground, and it was down a little bit below that. So I'm going to say that the ball, there's the height, I'm going to say the ball is something like that. So that's my prediction for the ball, right? And see, it basically it defined a little rectangle. Then you just draw an ellipse in that rectangle. So what's happening is that this curved surface is compressing the height of our cylinder and the height of the ball. But since it's a straight line across here in top view, it's not compressing the width as much as it is the height. Okay, it's curving more in this direction. It's straight in this direction. So there's a great lesson there, which is almost all convex positive curves will compress the reflection of the environment. So there's the ball prediction. Okay, and I said the horizon was slightly below the top of our cylinder. Let's just see how we did. Pretty close. Not bad. Okay, so it works. That's cool. That is getting you well on your way to thinking like a 3D modeling program, because that's what the modeling program is doing. So yeah, pretty close. And what about the reflection of the sky and all that stuff? We'll talk about that in the coming weeks, about the gradations, the colors, all that sort of thing, how to reflect the rest of the environment into it. Right now, this lesson, the most important thing is just to start to predict the big elements, like for instance knowing that everything up above here is going to be sky, everything below the horizon is ground, general position of the ball, general position of the cylinder. That's the big stuff this week. Okay, then we're going to talk about color, value, and gradations and all that stuff as we start to render in the coming lessons. Okay, this is our next scene. This is a part of a bigger curved surface, and it's in a vertical orientation. This is a lot like the vertical cylinder that we started with 2 lessons ago, and or 2 exercises ago, not to confuse my terminology. So we've taken that curved surface and put it in a vertical orientation, and I'm going to replay the same sort of things. It's going to be the exact same sort of construction, so I'll go fairly quickly through this one, and then we're going to move into an XYZ shape it's curving in all directions, and that's going to lead us into your exercise for this lesson. So line of sight rays again into that surface, bouncing out into our environment. Based on that, I can start to predict. I see that that line goes through the ball, so I'm going to place the ball there. And then I see, looking at this line, proportionally, it should probably even be a little bit thinner, is my guess, but that's almost half that distance, and this is a little bit less than half. And it looks like it should be crossing a little bit over to the side. I'm going to make a little adjustment here. I think probably right about there. Looks to be a little more accurate. And sight lines in side view, bouncing out into the environment. There's the height of our cylinder and our ball. So I'm going to take those back into my wall. There's the height of the cylinder. There's the height of the ball. And now we have enough information to go to those grid areas and predict where they're going to be here. Okay, now this construction is something new. That's why I went kind of this is just a replay of what we did on the other one. It's just flipped 90 degrees. But here I want to talk about something new. So I can see this foreground cylinder. I can also see where this wall hits the ground. And if I just imagine this as a right through the center here is a flat wall, now it's just like the previous flat constructions. And because of that, I should be able to draw a box, find the foreshortened center, draw through the middle, and then find this cylinder on the other side of that wall, which would be the reflection. Okay, because I'm just going to mirror it into that surface. So I'm going to treat it like it's a flat wall. So let me retrace this construction for you. Okay, so the first thing I know about my environment is I know, let's do it in maybe blue or something. I know a straight line on the ground. That's where the wall hits the ground. Okay, then I need to predict the height across. Here I actually know the side view, so I could actually just look down below and say, well, the height, right, is at the number 3 grid line. 1, 2, 3. So here's the height of the cylinder where it would hit that wall. So knowing that, all I have to do is draw from the side. Whoops, I'm just drawing freehand here. Draw from each side of this back to the vanishing point, to the horizon. So if I draw from this side, okay, through to here, there's the VP, so on the horizon. Now I have a plane here for the width. Okay, let me go to a different color. All I did then was draw an X to find the foreshortened center. There's the foreshortened center. And then I took that back to the VP. That was my midpoint between here and here. And I drew this from this corner, through the foreshortened center. Sorry, my bad. Through, right, half the distance of this line. And that takes, let's say this is point A, go through the middle of the other end of the box, and then that would be point A over there. And then I can draw straight across. That should be the position of the top of my cylinder in the reflection. And let's see. Yes, so that's the top. It's not the width, right, because it's a curve, but it's just the height. Let's change this opacity so you can see. Yes, look, the height of the cylinder, that's another way you could find the height of the cylinder. So just mirroring a plane into here will give you that height. Okay, in fact, it didn't even have to be this width. I could have just drawn this right all the way across. It has to just be any plane to give you, all you want is this dimension in front reflected into the mirror. So you just need the X and you need to mirror it in. But that's another way you could get creative and use perspective to plot that reflection. So that's just a little retrace of that. Again, I'll give you this layered file. All right. Okay, that is my prediction. Where did that come from? That came from these two examples over here. I knew that this box, right, I had the height. I could take it off of this construction, or I could take it off of this one, the side view, and I knew that it was just below grid number 2. So it's just below halfway was the bottom, so that's why I drew that there. The height came from over, the width, sorry, came from my top view. And then what about this ball? Well, the ball, now the curve's going the other way, so it's going to compress it. It's going to become a vertical ellipse, unlike the horizontal cylinder was just 90 degrees of that. And then I got my height from over here, so it was just overlapping the position of the cylinder, the bottom. It was just above grid line number 2. I got the width off of here, so I'm predicting, if you go in there and see the grid lines, you could actually find them here, but here you just have to, start to predict. that it's, if it's that height, it's half as wide. So that's, half as wide as it is tall. So there's the cylinder, and then there's the reflection. And yep, we got pretty close. Again, you can use all those constructions to help you predict where those guys are going to be. So that is the finish of that curved surface. And now we're going to move into an XYZ curved surface, which will be your big mind-bending exercise this lesson. Okay, now to put it all together. So when you start to plot reflections, as you're going to do this lesson, is you need to start to think about all the things we talked about so far: flat planes, cylinders, curved surfaces, and you're going to start to put them together and piece together points in space that are reflecting from your environment into your shiny surface. And then you're going to start to connect those points to create a picture, basically a warped picture of the environment around your object, and that's going to be your reflection. So let's look at this, and I want you guys to take a stab at reflecting this environment in another view. So that's going to be your big exercise, and then I'm going to provide you with the answer maybe towards the end of your homework period. So maybe after a week or so, I'll post up the answer. I don't want to give it to you right away. I want you to think and see if you can decipher it, and then I'll maybe halfway, during this first week, I'll post it up for you, and you can download it. So let's look at this before I turn you loose on trying to figure it out. So over here in the scene, we have a left vanishing point. So we have 3 lines basically on a ground plane, and they're going out to this dry lake bed, and then this black line is really a circle in top view. So this line here is a circle all the way around our object. Okay, so that gives us a nice dark line in the reflection of our horizon, sort of adding in with the mountains way in the distance. The mountains, because this is a HDR image out of a 3D rendering, the mountains are a little bit artificially high above the horizon, but that could just be a hill, and they could be up there. So you can use this as your horizon line, this dark black line. So that's our left vanishing point. Behind us, right, because these lines are parallel in top view, there should be another vanishing point. If we turned around and we looked behind us, we would see these 3 lines, okay, because they're parallel. They would be converging to a vanishing point that's behind us. And we can actually see that happening in the reflection. So I'm calling that the reflection vanishing point, okay, for these 3 lines that are out behind the camera. Then we have the sun, and the sun is floating in the dark part of the sky, and the sun reflection occurs wherever your line of sight bounces off the surface of this shiny shape up to the sun, wherever it is in the sky. And then look at the height of the cylinder. Okay, that's getting compressed because it's around. So what you want to think about, if I was going to plot the reflection of this guy, I would really just think about it in zones. I would say, well, this is a lot like a horizontal cylinder, right? I mean, yes, the ends are going to wrap, okay, but look at this. This is like a horizontal cylinder through here. I could even say that's partly like a flat plane, and where I could see these lines continuing, into that curved surface, right? If it was a flat plane, that line would just continue, actually it would continue and connect like all the way through to there. That would be, if this was a flat mirror like that, that's what that reflection would look like. So I can get that pretty quickly. I could get this pretty quickly. I can get this one, okay? But I have a curve. So then if you took and you combined that with a cylinder, okay, through here, you can say, well, thinking about this in top view, it's going to compress. Just think about a 45-degree angle here in side view. So if I had the cylinder and the ground, my camera, bouncing down, and I say, well, somewhere in here, my line of sight is going to bounce parallel to the ground. Okay, so there's the horizon. If I go here, it's going to bounce probably right down into there. So how far out is the stripe? That's probably somewhere right around in here. So if I just thought about a plane, okay, or thought about this as a cylinder and said about halfway down, it's probably going to reflect where this is. So you could actually start to predict that. And once you have those 2 points, it's getting a little bit fuzzy. Let me make a new layer. Once you have that location here and here, okay, you have a VP, which you could predict, again, thinking of it as a cylinder or a wall, okay, but really the cylinder, because now it's going to bounce, it's got to go behind us. It's no longer flat. And the curve is what's compressing that, right? So normally, before I said they're going off here to the left VP, but as soon as we make this a curve, so this shape in top view is like this, right? So if I start thinking about that in top view, and here's my camera, and I'm looking like this, well, that's seeing way over there, and it's seeing way over there. Here's my 3 stripes. Okay, where does it see the point directly behind me? Only at this point does my line of sight go directly behind us. Again, this is top view. Okay, and so that's where this line would, so that has to go to there, but these lines are parallel, so that means this line has to end up going to that position, and the reflection of it also has to end up going to that position, so that's going to bend them. Like I said, this is the hardest lesson of the entire course, so don't get depressed and despondent. This gets easier, and of course I'll be critiquing the work, and it'll get easier and easier every lesson. But unfortunately, this is where you have to start. So, line on the ground, you can probably figure out the position of that. Okay, then it has to go to that reflection VP. So, and it has to leave right here. It's reflecting what's directly behind it. So it's got to bend. So I have basically 3 points. I have a point here on the ground, and then I have to go through this point, and I have to get back to the reflection VP. If you know the sections of your shape, so the one out here, it's going to leave from right where it reflects itself. This one, if we just had a 45 plane here, we could probably just break that down into a plane, right? It's tilted towards us. Or we could just look at the side view again and think about that bouncing down to predict where that's going to be. Okay, and then now I have 3 points here, here, and all the way back to the VP. Here, here, all the way back to the VP. So that's how you start to predict those. This one gets a little bit tougher because it's a little further out. It gets getting up a little bit higher. So that's lifting up. But if we could see at a very small level there, or zoom in, it would actually be reflecting all the way through here. Again, 3 points. Once you knew it was hitting this shadow, right, you could break that down. I think once you see these, even if you did something like, let's say, well, it has to leave from here, and then it has to get back to the VP. That one's going to be a harder one, but even if you did something like this, okay, in a reflection that was in a sketch, it would totally be believable. It would really look like it's in its environment. And the amount of time, realistically, to go in and try and plot that and figure it all out, it's not worth it. So once you see it all working like this, you say, wait a minute, this is like a big stretched out sphere or kind of a rounded off cylinder. So I see this one going to a VP, this line goes to the VP, I bet this one has to do something similar. And then that tells you where the horizon, so in this case, wherever your line of sight bounces off of this shape parallel to the ground, that's where the horizon's going to go. Got a new notes layer. Okay. So you know the horizon has to be going through the same VP, and it's a horizontal line, right? So it's wrapping all the way through there, and then your line of sight's going to bounce off into the distance, so it has to wrap a little bit at each end, like this, as it's bouncing off to this part of the horizon over there. And the sky, let's not worry about the gradations yet. So for your homework, really all I want you to do is start to predict where the big elements would go, right? We know this cylinder is sitting on that line. So if we go along that line a certain distance, right? And how do we know how far? Well, we could just put in an artificial plane. We could project this over, go up. We could try to say, well, if it went in probably be somewhere, you know, around there. Is it taller going above the horizon? Yes. Okay. It's taller. I can see that it's taller than the horizon there. So that means it has to go up higher here. I know it's going to compress. So all I want you guys to try and do is get the big stuff in there. Don't worry about all the subtleties. Don't worry about this little curve. Don't worry so much about that bending. Um, but get the idea of the big stuff in there. So the ground, the sky, take a shot at the stripes, that sort of thing. So some basic guidelines there for you, the rules. Three black stripes are continuing behind our viewing position, right? So that's where this line would go, way off to the distance, and that's where the horizon would be. The sun is along this line somewhere up in the sky. So let's close that one. And let's open the one I'd like you to think about for homework. Okay, so first let me describe the scene you're working with, and then turn you loose on this one. Okay, so what I'd like you to do, and I'm not going to give it all away, but I will post up the answer, like I said, in a few days. But I want you to first understand the scene. There's actually a lot of information in here, a lot more than just predicting that perspective view. So I've given you the top view, and let me just point out where a few things are, because they're a little bit low contrast. Okay. Camera position is here, so effectively that's you standing in this scene looking at this object. Okay. The environment is exactly the same as it was for the previous one I just explained. It's the dry lake bed, low mountains in the distance, three stripes on the ground. Here's our three stripes, here, here, and here. Here's a little vertical cylinder there, and then I put two little vertical cylinders here, which are there and there. Okay, and then there's a yellow stripe on the ground. Let's see, the yellow stripe, it doesn't seem to be showing up here, but it's right here along this center line. That's where the yellow stripe is. Don't know why it's not showing up in that camera view. Here's my right side. So again, that's where you would be standing. Okay, looking at this object. So very low camera. Basically, you might be sitting down in this case, or this could be a big object. But your eye level, okay, is right about the height of the middle. Here's the post. You can pretty much ignore these little guys. I had put those in my original rendering so you could see the location of the sun. So let's not worry about that. The location of the sun, because then I was going to have you predict where the reflection of the sun is. But let's not sweat it for this week on that one. Because you really need to know, you really need to see the shadow. And if you had the shadow, then you would be able to predict with these two sticks. You would actually be able to predict the location of the sun in the sky, and then based on looking at these surfaces in these views, you can start to predict where does your line of sight bounce up to that same position for the sun, and that's where you put the reflection of the sun. Okay, we're going to talk a lot more about this sort of stuff, so don't sweat it so much this week. Just get your head around thinking in draft views, which is the most important part of this exercise. So I want you to start thinking top view, my position in relation to a shiny object that is reflecting the environment around it. Okay, that's most important. So let's just take this post for instance. So I'll give you a little hint here. Okay, my line of sight comes along, bounces off of here. Let me just switch this to a line tool. Okay, comes along, bounces. Then I predict out equal angle. Okay, I see that I don't see the post there, so if I go up here a little bit further and I look at equal angle, just missing it as well. Okay, so that means that probably between here and here is the reflection of that vertical post. So if I went to my guidelines, which you've got your grid on there, you could actually look and say, well, it's, let's see, right after that corner, which is here. That's there. It's 1, 2, 3, 4. No, 1, 2, 3. Just past 3 back. So that's 1, 2, 3. Probably right about in there is going to be the reflection of this guy. Okay, it'll probably curve a little more, but that's the general placement that I got out of top view. Okay, now what about front view? You see, it's just like doing the cylinder exercises. I up-res this, so it's pretty decent res. This is a little bit, obviously a little scruffy, so you have to imagine it's nice and smooth. Okay, so if I went back to the, I'm going to grab my line tool again. So I went back to my camera position, and I said, well, let's see, that's going to bounce down to the ground. That's going to bounce equal in, equal out. That's up to the sky. Probably it's going to have to be somewhere in between there and there. So it's going to be very, very short. So that's like in those two grid lines. So if I went back over to here, I might actually venture a guess and say that, let's see, where were those grid lines? The two just above the core shadow. So there's that core shadow. So probably going to be somewhere right in there. That would be my guess at the reflection of that. Again, what we're trying to do, you guys are trying to just this week sharpen up your observation skills, and ultimately we want you to be a very educated guesser. Okay, you just need to get very good at estimating this stuff to pull off the illusion of reality. Okay, so this is the hardcore physics week, bouncing stuff all around with constructions, but all of that's just to train your eye and train your brain to understanding why things are reflecting the way they are in photographs and in things that you see every day. So the last part of that discussion and the last part of your homework this week, let me close this one, is I'm going to put this photograph also in your file this week in the folder. And what I'd like you to do, and do this maybe with 2 other photographs of your own choice. I'm going to, let's increase this canvas size, just make that like 6. Okay, what I'd like you to do is take a photograph, and I'd rather have it be a photograph you take. Don't find it on the internet or something, because you need to know the entire environment that's around your object, time of day, what was around it, to fully understand the reflection. What I'd like you to do is observe this reflection. I'd like you to start to back out the schematic for that. And this we talked about at the very beginning of the day, this one. So I'd like you to draw like the cross section of the roof of this car and figure out where's the line of sight coming in at, right? And where does it bounce out, and what does it see in the environment, right? So here we had the sign, that's this sign. So that tells me the angle that it needs to be. And try to draw this proportionally correct. So if we have the roof of the car, right, and then we had this big building way over here. And so what I could see is that this part of the building is being blocked by that part of the sign. That means the sign is somewhere here on that same line of sight, because it's blocking that window way up there. This sign here, lamp post there, look at the post here reflecting into here. Okay, so I want you to start breaking that down into sections. Another great one is to think about if you have like the side of a car or something, think about the top view, or anything shiny. It doesn't have to be a car, it can be still life stuff. And I want you to find your position in relation to whatever the object is and start bouncing your line of sight into it and off of the shape. And then there are going to be things in your environment. Just label those and say, oh, when I was looking at this shiny shape, I took a photo of it, and there was a ball over here, and here was the reflection of the ball. And I want you to break that down into top view and look at that equal angle in, equal angle out. Okay? And whatever's here would be reflecting here in your shape. So do a couple of those constructions in addition to the real mind bender the XYZ shape one, which I will give you the answer to. And I think that's going to cover it for this week. So it's going to be a mind bender doing this one, of course, but I think try to have fun with it. Don't get depressed on me. We're just getting started. It will get easier, and it will start to make more sense. But unfortunately, when you want to start really getting good at rendering reflective surfaces, this is where you have to start. Plotting them into the surface, and then it gets much more fun. Just trust me.